So hi everyone. So in this class let me discuss a important concept, that is cyclic group. Cyclic group. For the definition of cyclic group is a group G is cyclic group if there exists an element A belongs to G such that G is equal to A. So that is, every element of G can be expressed as some integral power of A. Some integral power of A. And this A is called generator of G. Generator of G. So that is, G is equal to generator of A. So this is equal to A to the power n such that A belongs to G and n belongs to I. N belongs to I. So this generates, if G is a group, then from that group any of the element creates again that all the elements. So then that element is the generator of the Z. Generator of the Z. So for this example, if the operation of the group Z is addition, then G is equal to A. So this is the generator of the group G. Okay. So from A we can create 0, A minus A is 0. If we add it will become 2A. So another an element, if you add A 3 times 3A, so on up to infinity. So if you subtract A, so then it will become 0. Again you subtract 2 times A, then it will become minus A. Again you subtract A, then minus 2A. Okay. So like that you generate all the elements of the group Z. Okay. So then A becomes the generator of the group Z. So the definition of cyclic group is, there exists an element A belongs to G such that G is equal to cyclic group of A. So here this element A generates all the elements of group Z. So another example, that is, if the operation of the group Z is multiplication, then this A generates A to the power 1. So this is A. So another A, multiply A, then it will become A square. If you multiply another A, then it will become A cube. Like that you get A4, A5, A6, so on up to infinity. So if you multiply A to the power minus 1, then it will become minus A to the power 0, A to the power minus 1, A to the power minus 2, A to the power minus 3, like that. So you generate all the elements, okay, from A. So for this example, a simple example, that is 4th roots of unity is a cyclic group with respect to multiplication. E is 4th roots of unity is a cyclic group. Okay, is a cyclic group. So from these elements, any of the elements generates all the elements. Okay, so then that element is called the generator of Z. Generator of Z. So okay. So G is equal to 1 minus 1 I minus I, because 4th roots of unity are these elements. G is equal to 1 minus 1 I minus I, and your I belongs to Z. Okay. So here this is a multiplication case. So therefore 1 to the power 1, 1. Okay, 1 to the power 1, 1. 1 to the power 1, 1. Okay. So this is the identity element. Okay, 1 to the power 2, again 1, 1 to the power 3, again 1, 1 to the power 4, again 1. So here, so if you raise the power of this, you get an identity element, that is 1. Okay, so minus 1 to the power 1 is minus 1. This is not an identity element. Minus 1 to the power 2, you get here 1, minus 1 into minus 1. So this is the identity element. Yes, this is the identity element. But from 1 and minus 1, we can't generate the elements of group Z. But if you take I I to the power 1, I to the power 2 minus 1 because I square is minus 1, I to the power 3. So here I am multiplying I to the power 1 element I got here, I square minus 1, I to the power 3, I into I. Okay, so I square is minus 1 into I. So therefore we get here minus I to the power 4. So this is equal to I square is minus 1, I square is minus 1. If you multiply both to minus 1 into minus 1 is plus 1. Okay, so here from I we are getting all the elements, that is 1, minus 1, I, minus y. So therefore I is the generator of z. I is the generator of z, and we can express this in the form of definition. Okay, so again another element is there, minus I. So minus I to the power 1 is minus I square is what? Minus 1, minus I cube. I square is minus 1 into minus I is plus I. Minus I to the power 4, minus I to the power 4 because I square, minus I square is minus 1, again minus I square is minus 1 into minus 1 is plus 1. From minus I also we can generate all the elements of the group Z. Therefore here the generators of the group Z is 1 and minus 1, I and minus I. Okay, so here I am writing this in the form of z is equal to I to the power 4 is what? 1, I square is what? Minus 1, I to the power 1 is what? I cube is what? Minus I. Therefore z is equal to I to the power n. So if you put n is equal to 1, 2, 3, 4, you get all these elements, and all these elements value is what? 1, minus 1, I and minus I. Okay, therefore we can express this in the form of the definition of cyclic group. Therefore Z is a cyclic group. Z is a cyclic group where I and minus I are generators of Z. When we call these elements are generators of Z, so from that element we can construct the group Z, all the elements of group Z. So therefore these elements are generators of Z. So you know that order of a group. So order of the group is number of elements in that group, whether it is finite or infinite. Then we call that as order of the group. Like that here we are finding order of an element. Okay, so order of an element A belongs to Z, where Z is a group, then there exists a smallest positive integer n such that A to the power n is equal to E. Here also, then we say order of A is equal to n. If we raise the power of the element, then we get the identity element here. So here also, if we raise the power of I to the power 4, then we get the identity element. So then here for this I, the order of this element is what? 4. Order of this element is what? 4. So in the similar manner, minus I to the power 4 is there. So here the order of element is, because this is a multiplicative cyclic group, here if you raise the power of minus I to the power 4, then you get here the identity element, that is 1. So order of 1 is what? 1, because if we raise the power 1 to the power 1, you get here the 1. So that is the identity element. So if you raise minus 1 to the power 2, that will become 1. So this is equal to what? The identity element in multiplicative group. Okay. So therefore order of 1 is 1, order of minus 1 is 2, order of minus I is 4, order of I is 4. So therefore like that we can find the order of an element. So let me see the examples of order of an element. So here, if Z is a group of 4th roots of unity, Z is equal to 1 minus 1 I minus y. So with multiplication, then find the order of elements of Z. So solution for this is, so given that it's a fourth roots of unity. G is fourth roots of unity. Okay, so and it's a multiplicative group. Okay, so G is equal to 1 minus 1 I minus I. Okay, I minus I. So your Z is like this. Okay, so wholly like this. Okay, so order of 1. If you raise the power 1 to the power 1, you get 1. That is identity element, because your definition says a to the power n is equal to e. So then n is order of a. So here 1 to the power 1 is equal to 1. So therefore order of 1 is what? 1. So here order of minus 1. Order of minus 1. We have to find that. So if you raise the power minus 1 to the power 2, so then minus 1 into minus 1 is 1. So that is equal to identity element. So therefore order of minus 1 is what? 2. Order of minus 1 is what? 2. So order of I. So that we have to find. So if you raise I to the power 4, then you get the identity element 1. So therefore your order of I is 4. So like that we find order of minus I. If you raise I to minus I to the power 4, the power 4, then you get here minus I square is 1, minus 1, and minus I square is minus 1. Minus 1 into minus 1 is what? Plus 1. So that is the identity element. Therefore it is of the form a to the power n is equal to e. Therefore order of minus I is 4. Like that you have to find any group element. Okay, so here another example is there. So that is, if Z is a group of cube roots of unity. Okay, if Z is a group with cube roots of unity, so then find the order of elements of Z. So given that cube roots of unity elements are what? 1 minus 1 not minus 1 omega square with respect to multiplication. So then if you raise 1 to the power 1, that is identity element, that is 1. So here order of 1 is what? 1. So if you raise omega to the power 3, then it gives identity element, that is omega cube is equal to what? Omega cube is equal to what? 1. So that is the identity element. Therefore order of omega is 3. So omega square. So when you get the value of omega square, if you raise the power, how much power if you raise, then omega square gives the identity element. So omega square to the power 3. Okay, then it will become 6. So you know that omega cube is 1. 1 into 1 is 1. So this is the identity element. Therefore order of omega square is what? 3. So you now known that how to find order of an element. So now let me discuss how to find the generators of the group. Find all the generators of the cyclic group Z is equal to 0, 1, 2, 3, 4, 5 with addition modulo 6. So here the identity element in addition is what? 0. Okay, so if you how many times if you add 0, then you get 0 itself one time. So 1 times 0 is 0. Okay, so if you add 1 time 1, so then you get 1. If you add 1 time 1 2 times, then you get 2. If you add 1 3 times, then you get 3. If you add 1 4 times, you get 4. If you add 1 5 times, 5. And if you divide 5 by 5 divide 6, so remainder is 5 itself. So if you add 6, if you add 1 6 times, then you will get 6. And if you divide that by 6, so then the remainder is what? 0. So therefore order of, so here you got the identity element E. So this is also E. Okay, so here you got order of 1 is what? 6. Order of 1 is what? If you add 1 6 times, then you get 6. If you divide 6 divided by 6, then remainder is 0. So that is the identity element. Therefore order of 1 is what? 6. So if you add 2 1 times, you get 2. If you add 2 2 times, then you get 4. If you add 2 3 times, then you get 6, and if you divide 6 by 6, then the remainder is 0. So here you get the identity element. So therefore order of 2 is what? 3. So if you add 3 one time, you get 3. If you add 3 two times, then you get 6, and 6 divides 6, then the remainder is 0. So that is the identity element. So therefore order of 3 is what? Order of 3 is what? Order of 3 is what? 2. So next, if you add 4 one time, you get 4. If you add 4 two times, then you get 8. 8 divides 6, then remainder is 2. Okay, so if you add 4 3 times, then you get 12. So 12 divides 6, then remainder is 0. So that is the identity element. Therefore order of 4 is what? 3. Next, 5. If you add 5 one times, you get 5. If you add 5 two times, so then you will get 10. 10 divides 6 is 10 divides 6, then the remainder is 4. If you add 5 3 times, then it will be 15. 15 divides 6. 15 divides 6, then the remainder is 3. If you add 5 4 times, then you will get 20. 20 divides 6, then the remainder is 2. Okay, like that. If you add 5 times, then you will get 25. 25 divides 6, then the remainder is 1. If you add 5 6 times, then you will get 30. 30 divides 6 is the remainder is what? 0. Therefore that is the identity element. That is the identity element. Therefore order of 5 is what? 6. Order of 5 is what? 6. From which elements you generated all the elements of the group Z? So from 0 you won't got all the groups of the elements. Okay, so then you leave it. So this is not the generator. So from 1 we got all the generators of Z, that is 0 1 2 3 4 5. Okay, so therefore this is the generator of Z. 1 is the generator of Z. So from 2 we didn't got all the elements of the group Z, therefore it is not a generator. So from 3 all the elements of the group is we won't constructed here. So therefore this is not a generator of Z. From all 4 also we can't find all the elements of group Z, therefore this is also not a generator of Z. So from 5 we got all the elements, that is 1 0 1 2 3 4 5. Therefore 5 also the generator of Z, because from 5 we constructed all the elements of Z. Therefore 5 and 1 and 5 are the generators of the group Z. So order of 1 and order of 5 are 6. So that is the order of Z. So here order of means order of this group is what? Order of this group is what? Order of this group is 6. Okay, so therefore here also if you raise the power of means if you add 6 times, then you will get 0. So if you add 5 6 times, then also you get 0. Therefore order of the group and order of the element also, order of the element and order of the group both are one and same. So therefore here 1 and 5 are the generators of Z. So next another example. So from this you can understand how to generate the generators of the cyclic group. Find all the generators of the cyclic group. Z is equal to 1 2 3 4 multiplication modulo 5. So here order of the group Z, number of elements present in the group, that is the order of the group, that is 1 2 3 4. So here 4 elements are there, therefore order of the group Z is what? 4. Now we have to find its generators. So let me see that. If you multiply 1 times, then you will get 1. So that is the identity element. So that is, therefore order of 1 is what? 1. If you raise the power 2 into 2 to the power 1, then you will get 2. 2 to the power 2. 2 into 2 is 4. Divided by 5, remainder is 4. 2 to the power 3. So this is 8. 8 divides 5, then remainder is 3. 2 to the power 4. 2 to the power 4 is 16. So divided by 5, remainder is 1. So this is the identity element. So this is the identity element, the identity elements. Therefore order of 2 is what? 4. So 3 to the power 1, 3, 3 to the power 2, 9, 9 divides by 5, remainder is 4, 3 to the power 3, 27, divided by 5, 2, so 3 to the power, maybe it is 81, 81 divides 5, remainder is 1, so therefore order of 3 is 4, 4 to the power 1, 4, remainder is 4, okay, 4 to the power 4, so here you get, the remainder is 4 itself, okay, 4 to the power 2, so that is 16, 16 divided by 5 is 1. So therefore, so this is the identity element, okay. So order of 4 is what? 2. So if you raise the power 4 to the power 2, then you will get here you get identity element, therefore order of 4 is 2. From which element we find constructed all the elements of group Z? So 1, 3, 4, 2. So from 2 we constructed all the elements of the group Z, therefore 2 is the generator of Z. So again we check which element constructed the elements of group Z. So this is 3, 4, 2, 1. So from 3 also we generated all the elements of the group Z. Therefore 3 is also the generator of the cyclic group Z. So therefore clearly 2 and 3 belongs to Z, such that order of 2 is also 4, and you know that order of Z, so this is also 4, so order of 3 is 4, and also order of Z is also 4. So here generator of the means generators of Z, their order and order of group are one and same. Therefore 2 and 3 are generators of the cyclic group. So from which element, if we generate all the elements of the group Z, those are the generators of the cyclic group. So another example, the group Z4. So in Z4 you get 0, 1, 2, 3 with addition modulo 4 is a cyclic group. So find out the generators of this cyclic group. So if you add 1 times, so then that is 1. If you add 1 2 times, then you will get 2. If you add 1 3 times, you get 3. If you add 1 4 times, you get 4. Divided by 4, you get the remainder is 0. That is the identity element of this group. So 2 times 0, 2 1 times. If you add 2 1 times, then 2 plus 2 0, 2. If you add 2 3 times, you get 2. If you add 2 4 times, then you will get, that is 8 divided by 4, remainder is 0. Here you construct elements only 0 and 2. Here 1 2 3 4, 1 2 3 and 0, 0 1 2 3. So from 3, so if you add 3 1 time, 3 2 time, that is 6 divides 4, remainder 2. If you add 3 times, then you get 9 divided by 4, remainder is 1. If you add 3 4 times, that is 12 divides 4, remainder is 4, remainder is 0. So here 3 also constructed all the elements of group Z, and 1 also constructed all the elements of group Z. If you add 0 1 time, you get 0, okay, 0, okay. So therefore order of 0 is what? 1. Order of 1 is what? 4. Order of 2 is what? 2. Order of 3 is what? 4. So therefore the order of Z is what here? 4. So order of Z and the generators of Z are, their order is 1 and same. So therefore here the generators are 1 and 3. From 1 and 3 we can construct all the elements of group Z. Therefore the generators of the group Z4 is 1 and 3. With this I conclude today's class. So if you have any doubts regarding these examples or definition, you can send your questions to my WhatsApp number and clarify your doubts. Thank you.